Hey, thanks for watching Practical Solutions. My name is John, and today we're going to be going over DMVPN in a snapshot. So DMVPN overview. According to Cisco, a dynamic multi-point VPN, or DMVPN, is a Cisco iOS software-based security solution for building scalable enterprise VPNs that support distributed applications such as voice and video. In my terms, I'm saying that it's a dynamic tunnel network that optimizes spoke-to-spoke network traffic as you progress through the DMVPN phases. In a DMVPN phase 1, the hub does all the NHRP registering and lookup to identify the proper non-broadcast multi-access to the tunnel IP address for each spoke. In most cases, you're going to see that the non-broadcast multi-access IP address they use is going to be your internet IP address, which is going to be your underlay. And then your overlay will be your tunnel IP address. The hub keeps this entire database so that when a spoke needs to communicate with another spoke and they only have the tunnel IP address, they can get the underlying IP address from the hub. In phase 2, we see this restriction easing as now we move to multi-point mGRE tunnels on the spokes and introduce the no IP next hop self on the hub if you're using EIGRP. We can also add our own crypto peers at this time on the spokes, not just on the hub, because now you're going to have spoke-to-spoke communication, and if you're using any type of encryption, you now can build those crypto mappings and those crypto relationships with your peers, not just the hub. And now that we have spoke-to-spoke communication with the mGRE, there is no more defined tunnel destination on your DMVPN. In phase 3, the DMVPN is fully dynamic with the commands IP NHRP redirect on the hub and IP NHRP shortcut on the spokes. We're allowing that direct spoke-to-spoke communication and require even less hub interaction. The hub pretty much is passing us off once we get our non-broadcast multi-access IP address. And they can go ahead and be like, here you go, and you send yourself off. And the spokes can communicate one-on-one. So what is NHRP? NHRP, or Next Hop Resolution Protocol, is designed to work on non-broadcast multi-access networks. In DMVPN, NHRP is the link between the underlay network and the overlay network. The hub acts as the next hop server, or NHS, while the spokes are the next hop clients, or NHCs. The hub keeps the NHRP database, like we spoke to before, with the public interfaces or the public addresses, the non-broadcast multi-access of all the spokes. Each spoke must register its real address, so that underlying address, with the hub, so it can look up the addresses for other spokes via this NHRP database that the hub maintains. So this database maintained on the hub links the tunnel IP address to the underlying IP address, the non-broadcast multi-access. Now down here, you can see where it shows you the interface, tunnel 0. It's our NHRP details that we have here. Shows that we are the hub and how many peers we have. Dynamic peering, because these are spokes and we're the hub. And then if you go here, you can see the peer non-broadcast multi-access. In our example, we used a very simple IP scheme, and then that links this to the overlay tunnel IP address. So what the spokes have initially are the tunnel IP addresses. They can talk to each other through the routing protocol over here. But what they need additionally is the underlying address. And to get that, they use NHRP, and that NHRP resides on the hub. So the hub handles all of the NHRP requests. So DMVPN key components. So the big and major factors in a DMVPN, there's only primarily 3 things. It's a multi-point mGRE tunnel, or a GRE tunnel, which uses IP protocol 47. It's a 24-bit header. It can be CPU intensive, so on a hub that's not, a beefed up router, something like an ISR 1K or even an ASR 1K, something like that. If it's a little bit slower, like maybe an older Cisco 800 series, like an old one, the CPU might take a hit, especially if you have a pretty intense DMVPN network, especially if you're using crypto or any type of encryption. mGRE and GRE is not encrypted organically by default. IP fragmentation is possible, so pay attention for OSPF. Tunnel MTU will be something you'll have to play with if that does happen. And then it allows the support of multiple GRE tunnels on a single interface with the multi-point GRE, which is part of the dynamicness of DMVPN. NHRP is the client server protocol, as we spoke to before, which includes the NHS or the hub. maintaining the registered spokes, public IP address, and tunnel IP address mappings in that NHRP database. And then finally, we have IPsec, which secures and encrypts tunnel traffic. IPsec and encryption, I'm going to do another slide on, because that in itself, I don't want to just step on. It's pretty detailed, especially working like version 2, and you're not using crypto maps, and you're using tunnel encryption or tunnel protection, excuse me. It's a little bit more in depth. So we'll go through that in a separate video as well. Now let's go through the phases. All phases for the underlay are the same. So the underlay network, also known as the transport, will involve basic connectivity between the spokes and the hub to include some form of routing. Forgive the barbaric caveman drawing, but I want to just kind of get the idea. We don't need to have little routers and all that stuff. The underlay or transport is whatever network you're using, could be private or public, like the internet. And then you have your spokes, and your spokes are using this underlay transport network to get to the hub. So in most cases, you also might find VRFs separating the over and underlay networks in the tunnel. This is common in enterprise networks. Nothing to be afraid of, just something to be aware of and how VRFs work. Remember, a VRF is very much like a VLAN. It is an isolated network, and it has its own routing table. For DMVPN, most underlay networks will be the internet. In most cases, I've always dealt with internet or some form of public communication network. So for DMVPN overlay for phase 1, this is the diagram that I chalked up. All the spokes are trying to talk to the hub over those tunnel IP addresses. So they're all registering with the hub, with NHRP, getting their mappings done for the hub, and then any spoke-to-spoke communication relies solely on the hub. So phase 1 involves static GRE point-to-point spoke tunnels to the hub. And we define the tunnel destination on each tunnel. So it's very manual, very, very manual labor, and very manually intense, especially if you have 20 plus sites that you have to do. Now, it's easy. 20 plus sites isn't that bad if you've done it before, but if you're doing it for like 100, this would have been this is where automation would have been key. The hub is an mGRE tunnel, so in all phases, the hub is dynamic. And the spoke tunnels rely solely on the hub, as we said before, for all communication redirection. In phase 2, it's a little bit different. Phase 2 begins to open up the hub and spoke topology we saw in phase 1. In the diagram I drew here, it's pretty much the spoke hitting the hub and then being relayed to the spoke. So we're now introducing mGRE on all spoke tunnels. So now all spoke tunnels are multi-point, generic route encapsulated tunnels. Spoke-to-spoke traffic is now permitted, and spokes still rely on the hub for the underlying address of your DMVPN peers. So with this spoke-to-spoke communication, if you are using encryption or you're using old school crypto maps or anything like that, nothing wrong with them, you can still use them. You have to make sure you put in your peers. So if you have, in IKE version 2, if you have all quad zeros, you're allowing everybody using a PSK or what have you, make sure all that matches through all your peerings and all your peers and spokes. And then also make sure anything else that you're using for crypto, so let's say crypto maps or anything like that, make sure you've added in all those peers as well in your IceCamp statements. And then on to phase 3. So finally we get to phase 3, and it's a lot more colorful. With phase 3, you now have spoke-to-spoke communication, less reliance on the hub. The hub's still here, but it's not as intense. And the idea of the phases in phase 3, the DMVPN is completely dynamic. Spokes can now talk to each other as needed. The hub introduces the IP NHRP redirect command, and the spokes introduce the NHRP shortcut command into their tunnel configurations. NHRP allows the spokes to talk dynamically with less reliance on the hub in phase 3. And now the NHRP database that they register with the hub is being more lenient with the IP NHRP redirect and handing off the spoke communication for the spokes to handle themselves. So you see it becomes less intensive on the CPU being a phase 3 versus a phase 1, where everything is being ran through that hub. So this is the DMVPN states that we have. I saw this in another video. Someone kind of broke down the steps with arrows, and I really liked it. So I'm doing the same thing here. These are troubleshooting commands based on your phases. So on the state, we'll go back to the video. I'll go back to the slide and show you here where we have state, where it shows up. As your DMVPN establishes, and you type in show DMVPN, you'll go ahead and you'll see the phases change. So INTF, if you see INTF in state, it's a good chance that the line protocol is down. Some troubleshooting things that you can shoot for as far as commands, you can do a show DMVPN to confirm it's INTF, then show IP interface brief on that interface to find out if something's wrong with that line protocol or if something's wrong with your tunnel. So you do your show interface tunnel and double check all your configurations and make sure you have pingability and routability in your underlay network. Same with your overlay. You want to make sure that if you're using any type of routing, that anything in there that you've configured is correct on both sides. As we move and go to the IKE phase, where this is the exchange of IceCamp information, this is where you're going to get into the crypto commands, where show crypto IceCamp SA, show crypto IKE version 2 SA, and then your commands to debug them would debug crypto IceCamp or IKE version 2. And that will go ahead and get you started for debugging your IceCamp and your IKE version 2 SAs. You can always go into your show run pipe section crypto and check your configurations there as well. And just make sure that your configurations match the hub and spokes as you have set up. Everybody's different, right? Some people may have specific ways that they want to exchange information or authenticate. I choose PSKs because they're the easiest, especially for a study. So I recommend that. And then for IKE version 2, the quad zeros, just so you get familiar with how that crypto builds, it's easier to do it that way. And then you can break off and do specific peerings if you'd like. For IPsec, you'll also see this portion start pop up. This is in between the IKE and NHRP phase, so it also can be a hang-up phase in your DMVPN. You will also use the same crypto commands, but a little bit different. So show crypto IPsec SA, because now you're on phase 2 of that crypto relationship. So now that you have your IKE information confirmed, now you're moving to your IPsec or any type of configurations as far as encryption goes. So it'd be your show crypto IPsec SA and show crypto session detail. You can debug IPsec with debug crypto IPsec. Now, if you're using tunnel protection on your tunnels, again, you can go to show run pipe section crypto and double check, make sure all of that, anything that you put in there for IPsec matches your neighbors. It's going to be important, especially when rolling out larger deployments. If you have things that are very unique, make sure that they match on both ends. And then this leads us to NHRP, which you'll also see IKE and NHRP. You'll see a slash in between them. So sometimes it's not just one status. You'll see a couple of things in there, so not to confuse you. But this could be another issue. You'd be running a show IP NHRP and then debug NHRP to figure out what your NHRP issues are. In your tunnel configurations, it would be something that could be there. If you do have an issue with NHRP, I can go ahead and pop that up after this to show you, and we can run through where you're going to find these again in case you've forgotten. And then your up phase to finally confirm everything's good is show DMVPN and show IP NHRP. In show DMVPN, you should see up for your neighbors, and you shouldn't have any discrepancies as far as displaying IKE or NHRP in the statuses, because it can show IKE, it can show NHRP, it can show IKE/NHRP, and so these are the phases that you can get hung up with. So I recommend understand these phases, understand what these commands do for these phases, so that way when you see this, you know exactly where to go and troubleshoot, so that way you don't waste any time. And that is it. Thank you very much for watching Practical Solutions. My name's John. I'm going to give a couple more minutes to jump in, because I did tell you I was going to go over one more thing. Let me go ahead and jump in here now. All right, so we're inside of our topology here, and I had this started up anyways. So show DMVPN, and we can see the mappings that we had before, and the status is up. If I go ahead and I pop over to a branch, enable, show DMVPN. Now I only have static because I haven't done any dynamicness or any type of resolution with branch 2, but if I want to do branch 2, we can just run a simple ping. I can ping its overlay, ping 172.0.0.3. All right, and now we have the dynamicness. So if you do see things in the state, you would see your IKE NHRP. This is where you're going to see the issues here. And then depending on what you're going to be using for tunnel protection, so if I do show run interface tunnel 0, because that's what I chose to use, I don't have tunnel protection on here. But your NHRP mappings, when you have NHRP issues, you want to make sure that this is correct. You want to make sure on your spokes that your underlay matches with the overlay. Make sure that your mappings are correct. The NHS is going to be your overlay IP address, so this is going to be your tunnel IP address. Your NHRP map is going to be your overlay to underlay, and your multicast will be your underlay. So always think non-broadcast multi-access. Your multicast is going to that IP address. Your overlay is going to be your mapping of over to under. Your mapping is going to be your overlay to under mapping, and then your NHS is going to be your tunnel IP address of the hub. So not to confuse you there. But if you have any questions, comments, go ahead and drop them down below. Let me know if you want any more clarification. I just did this video quickly. I'm going to go ahead and do a few other videos, put them out there so people get a better idea for DMVPN. Because what I see now, a lot of the engineers that I work with, is there's a lot of confusion on how a DMVPN works, what actually is going on in the background between the hub and the spokes. So if you have any questions, go ahead and drop them, and I appreciate you taking your time to watch the video. Take care. Thank you very much.